For the first lesson in Chamat, we will be reviewing matrices. What are the objectives of this lesson basically? Student outcome A, ability to apply knowledge of mathematics, physical sciences, and engineering science to the practice of chemical engineering. Outcome J, which is techniques, skills, and modern engineering tools necessary for the practice of chemical engineering. And then for the learning outcomes, basically LOs 1, 3, and 4. So for matrices, a matrix is an array or basically an arrangement of numbers in a rectangular manner. So what do you call, guys, these inputs or these entries in a matrix? They're all called, very good, they're all called elements of the matrix. So the matrix typically is represented by a capital letter, and then the elements of the matrix are enclosed in vertical bar or sometimes square brackets or sometimes big parentheses. M and N are what you call the dimensions of the matrix, wherein M is actually for the number of rows, and N here is for the number of columns. So for example, Aij, I also is for the row, J is for the column. So if I say A33, that's the element in the third row and third column. So ang row natin, guys, if I ask you which is the row, which is the column, which is the row? Is it the horizontal arrangement or the vertical arrangement? Horizontal is the row, and then the vertical arrangements are the columns. Very good. Also, some special properties of the matrices are this. For example, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? This is what you call a 3 by 3 matrix. Right? So, what is A22, A31, and A12? What is A22, guys? 5, very good. What about A31? 7, very good. A12, it's 2. So you know where to locate those elements. Also, matrices are defined by square matrices, of course, they're defined by their diagonals. The yellow one is what you call the main diagonal, and then here, the blue is the secondary diagonal. So this one is what you call the main or primary diagonal. And then this is the secondary diagonal. Let's go to the next. So here, can you just tell me what are the dimensions of the matrices? A is, yes, 2 by 2. What about B? 3 by 1. Very good. C is 1 by 4. And then D is 3 by 2. Now I have a question. Letter D and letter C contains letters or variables. Are they still considered matrices? Yes. Kasi take note that matrices can contain, di ba, numbers, letters. They're still elements of the matrix. Now, for these matrices, there are special names. As I have said, if the number of rows is equal to the number of columns, this is what you call a square matrix. What about 1 by 4? Do you have any idea on what it's called? This is a special matrix as well. This is what you call a row matrix. Whereas, of course, if that's the row matrix, this is what you call the column matrix. Whereas a 3 by 2 matrix is simply just a 3 by 2 matrix. So let's go to the algebra of matrices. We have, of course, the first is addition and subtraction of matrices. First question, A is a 2 by 2 matrix. B is also a 2 by 2 matrix. C is a 2 by 3 matrix. Am I correct? All right. So for A plus B, can I add them? What is the sum of matrices A and B? Let's start with the first row. -1 and 6. What about the second row elements? 3 and -2. Very good. A minus B. First row elements. 1 and 2. Second row. 3, 4. Very good. A plus C, guys. A plus C is not possible. Very good. Why? Because for us to be able to add or subtract the elements or the matrices, the elements have to have a counterpart. Look at the dimensions. The dimensions of A and B are the same, whereas C is different from A and B. So this one is null set, or sometimes you place it like that, null set, because you cannot subtract them or add them. Okay, so B minus A, guys. First elements, go. -1, -2, very good. What about the next? -3, -4. Okay. What about C minus A and C minus B? What do you notice? Null set. Null set. You cannot perform addition or subtraction in C and A, between C and A, C and B. But it does not necessarily mean that if you cannot perform addition or subtraction in those, you can also not perform multiplication. I'll show you later on if we can or cannot perform multiplication. So at least addition and subtraction are quite clear. Let's go to the next operation, the multiplication of matrices. In multiplication of matrices, there are two types. One is scalar, just like in your physics. What do you mean by scalar? Magnitude without direction as defined in physics. Very good, di ba? Scalar quantities. So just like that, when I say scalar multiplication, it's just a number or a letter multiplied to all. So for example, the base magnitude is 3, tas ang scalar multiplier is 2. Eh di lahat ng items, i-multiply natin ng 2. So in this case, you just multiply 2 to all the elements. That's 0, 8, 6, 2. Right? In here, multiply 1/2 to all the contents of B or all the elements of B. -1/2, 1, 0, and -3/2. So for letter C, multiply by letter K. It's just 2K, -K, 4K, 0, K, and -3K. And then sometimes you can add matrices with with other operations so long as they have the same order pa rin, 'di ba? Same dimensions. So -2A is 0, -8, -6, -2, plus 3 times B. So -3, 6, 0, and -9. This would give us what? Can you please add for me? -3, -2, -6, and -11. Okay. So that's the correct answer. So it's easy if it's scalar multiplication. The problem is when we're dealing with the matrix multiplication or yung mga vectors na. All right, let's go here. What are the dimensions of A and B? A and B are both
2 by 2 po.
2 by 2. Of course, B and A is also 2 by 2. A is 2 by 2 at saka yung B. What about C? 2 by 3. Very good. So what happens is this. With me, I use this rule, the rule of means and extremes. So means and extremes. Means and extremes. Okay. Are the means the same value? Yes. 2 and 2. Are the means the same value? Yes. Are the means the same? Yes. Are the means the same? No, not the same. So that means if the means are the same, you can multiply them. You can multiply the matrices. And the extremes actually give us what is the dimension of the final answer or the final matrix. Here, it's 2 by 2. In this case, the final answer has dimensions of 2 by 3. Whereas lastly, you cannot multiply this because the means are already different. Okay, so please take note of the matrices. We'll be using them for our multiplication. So when we're multiplying A by B, you have to remember that the multiplication is always row by column. So when I say row by column, what I do, guys, is this. I encircle the row, I encircle the columns. Pero ako, I just encircle one, at least a representative. Why? Because of this. If I say A times B, I do this. I know, di ba, it's a 2 by 2. So the reason why I encircle this is, let me ask you, what is the element here? Element A, what? What's the number of row and number of column? In this one, upper left. What is the position of the upper left in terms of number? Element A, 1, 1. Very good. A, 1, 1, meaning first row and first column. So look at the ones encircled on top. What did I encircle in letter A, guys? Elements in the first, first row. What about sa B? Anong naka-encircle? First column. So that means when I multiply the first row to the first column, 1, 1 ang lalabas. When I multiply the second row to the first column, 2, 1 ang lalabas. So 0 times negative 1 is 0 plus 4 times 0 is still 0. Now, first row, second column. 0 times 2 is 0. 4 times negative 3 is negative 12. Lower. 3 times negative 1 is negative 3. 1 times 0 is 0. Next, 3 times 2 is 6. 1 times negative 3 is minus 3. So that means A multiplied by B would give me 0, negative 12, negative 3, 3. It is a 2 by 2 matrix. Now, if I ask you B multiplied by, so I'll just write here, negative 1, 2, 0, negative 3 multiplied by A, which is 0, 4, 3, 1. Again, row by column. So let's encircle a sample. Row, sample, column. So for this one, guys, can you please tell me what is B by A? Let's create the circles first. All right, guys, what's the first entry? 6. Sige, 0 plus 6. Next is -4 plus 2. Next is 0 minus 9. Lastly, 0 minus 3. Very good. So the final answer is 6, -2, -9, -3. This is B by A. What you'll notice, guys, is bakit ganon? A multiplied by B and B multiplied by A are not the same because you have to take note that matrix multiplication is not commutative. That's one of the properties, okay? Next. For example, if I ask you A by C, I said earlier, A by C can be multiplied. Sorry. A has dimensions of 0, 4, 3, 1. C has dimensions of, as in dimensions, elements 2, -1, 4, 0, 1, -3. So in this case, you would want to multiply A by C. So let's encircle a row and a sample column. Let's go to A by C. Let us create our circles. Okay. Can you please help me fill it out? For the first one, 0 plus 0. Sige, tuloy-tuloy lang ha. Next is 0 plus 4. Next is 0 minus 12. Very good. Next is 6 plus 0. Negative, -3 plus 1. Next is 12 minus 3. Very good. So that means this one, the final answer would be 0, 4, -12, 6, -2, and 9. Okay? Any problem? Okay. So let's go to the next. So one of the properties of a matrix is that it has what you call an identity matrix. What is an identity matrix? What you will notice in here, guys, is that an identity matrix is a matrix whose main diagonal is 1. And then the other elements are 0. So this is a 2 by 2 matrix. This is a 3 by 3 matrix. Only square matrices have identity matrices. Okay? Pag hindi siya square matrix, huwag mo siya i-consider na may identity. This is only a property of a square matrix. Okay? I said earlier that when you multiply matrices, the commutative rule does not apply. However, when you're multiplying it with an identity matrix, any matrix A multiplied by 1 is the same as 1 by A. It's the same as A. Kaya nga identity, bumabalik siya. And then at the bottom, this is what you call a zero matrix. Zero matrix basically is a matrix whose elements are all zeros. Ngayon may tanong ako, guys. Bakit ba kailangan natin ng identity matrix? Second, bakit ba kailangan natin ng zero matrix? I want you to think of that. What's the purpose of having an identity matrix? What's the purpose of having a zero matrix? Solving problems? Yes. Kasi bakit? Sometimes, kunyari, you have to remember that a matrix can only be added to another matrix. So, kunyari, meron tayong scalar that you want to add to a matrix. For example, isang matrix, 3, 2, 1, 1 plus 5. 5 ano? 'Di ba? So, hindi siya pwedeng i-add kasi one is scalar, the other one's a matrix. So, ginagawa natin minsan, kung identity lang naman, i-multiply natin siya sa identity matrix so that magiging matrix. Yung isa naman, kahit na ba 0 lang yung i-add mo, 0 is scalar, hindi pwede. In order to make it a matrix, kailangan sa zero matrix mo i-add. It's important in solving. So again, the laws governing matrices. Sa matrices, associative rule and the distributive rule applies. So A plus B plus C, you can add B plus C first. Or in multiplication, when you multiply A and B, so long as dapat yung order the same ha, hindi pwedeng bumali-baliktad kasi commutative rule does not apply. So look at the one here, the one on the side. For example, look at the means, 'di ba? Look at the means. The means here, P and P, it's correct. So you can multiply them. It gives rise to an M by Q matrix. Tapos, this one gives rise to P by N matrix. Let's go to the top. 'Di ba, kapag yung ginawa ko, yung operation on top, M by P matrix multiplied to a P by Q matrix, it's an M by Q matrix. Now, M by Q multiplied to a Q by N, these are the same. So that means it gives rise to an M by N matrix, which is this. Whereas kapag inuna ko yung nasa dulo, a Q by Q, they're the same. So it results to a P by N matrix. And then this one, when multiplied, pwede rin. It results to an M by N matrix. So still, the left and the right are the same. Pwede pala siya. Kaya nga, it proves that associative rule applies. So distributive property, you know naman distributive rule, right? So you can apply that as well. Now, let's go to the next. The determinant of a matrix. Guys, the determinant is very important because it's actually a number, it's a single number that represents your matrix. So sometimes, etong matrix na to, pwede ko sabihin, that's equal to 2 or that's equal to 4. So matrix A is equal to 4, for example. So it's a number that represents your matrix. That is what you call the determinant. It's a single number. But a determinant is only a characteristic of a square matrix. If it's not a square matrix, you can never have a determinant. Now, how do we represent, or what's the notation that we used for determinant? So we use det A, meaning determinant A, or two vertical bars that enclose letter A, right? So we have two matrices A and B here. There are actually two ways in solving for determinants that I'll be showing you. So the two ways are the diagonal multiplication in solving for the determinant. Paano ba yun? I'll give you the formula first. Determinant A is basically the summation of the products primary diagonals minus the summation of the products of secondary diagonals. So, what does this mean? A is 2, -1, -2, 3. There. So, products of the main diagonals. So, main diagonal. And then secondary diagonal is this. So, in this case, you'll notice that when we place those lines, they have covered all the numbers already. So, wala na tayong ibang kailangan. So, in this case, 2 times 3 is 6 minus -2 times -1 is 2. So that means here, 4 is the determinant of A. Ayusin natin ha. So this one, I'll just write here. The determinant of A is 6 minus 2 is actually 4. Whereas for B, 1, 2, 3, 0, 4, -1, and 0, -3, 2. Alright. So the problem here, guys, is this. When you draw the main diagonal, ito siya. The secondary diagonal is this. Ang problem, guys, we have not touched all the numbers. Yung 0, 2, -1, at saka -3, hindi natin na-touch. So how do we do that? What we do here is, we copy the first two columns and then extend the parallels of the diagonals. There. Ito. Some of you might say, asan yung 4? Ayun, na-touch na natin yung 4 nung unang beses. Nasan yung 0? Ayun, na-touch na siya dito. So that means all the items have been considered. So the determinant of B, I'm showing you that I use this at times and then at times I use the word depth. Okay? What's the determinant? Can you give me the sum of the products of the primary diagonals? So it should be 8 plus 0 minus 0 plus 3 plus 0. So it's an 8 minus 3. The answer is 5. So this is one way, diagonal multiplication. There is another way. The other way is what you call expansion by minors, or what you call cofactors. So, ano ba yung mga minor na yan? For example, 2, -1, -2, 3, B, 1, 2, 3, 0, 4, -1, and 0, -3, 2. So if I say minor of A, 1, 1, minor of A, 2, 1, of B, 2, 3, of B, 1, 3. What are the minors? What you do is, minor of A11, where's A11? This is 2, right? So what you do here is, you cover the row and the column that contains that number. So row and column, cover to, cover to. What's the number left? What is the number left if you cover the row and column containing 2? The number left is 3, so that's correct. The answer is 3. What about A21? 1, it's -2. So the number left when you cover this row and column is what? -1. Very good. Now, the thing is B23. B is a 3 by 3 matrix. So when I say B23, second row, third column, oh, that's element -1. So you cover the row and the column of the lines containing -1. What is left is another matrix. Then yung problem, guys. 1, 2, 0, -3. Ito yung minor niya. Right? And then, of course, this one, you can still solve this. You solve the determinant of this. Kasi di ba dapat ang minor niya isang number lang din. Ito. What about 1, 3? So, the numbers are 0, 4, 0, -3. So what are cofactors? They're what you call signed minors. And then for signed minors, we follow this rule on signs. -1 raised to I plus j. What do I mean by that? -1 raised to 1 plus 1 is positive. Ito, 1 plus 2, negative. 1 plus 3 is positive kasi magiging 4, di ba? And then, sa 2, 1, 2 plus 1, it's 3, so negative siya. So you'll notice that it becomes like this. This is what you call the array of signs. So how do we apply the cofactors, guys? If I ask you cofactor of A11, cofactor of B, let's use the same numbers, B23, A21. So cofactor A11, look, A11 is here. First element siya, right? So the sign is positive. And then, what's the minor? Kasi sabi sign minor. So positive daw siya na 3. 2, 3. Where's 2, 3? 2, 3. Anong sign niya? Di ba the sign is negative? Kasi 2 plus 3 is 5. Negative 1 raised to 5, it's minus. So minus what? Isn't it that yung minor niya was already solved on top? So 2 here. So that is the cofactor. Whereas A21, 21, 2 plus 1 is 3. So dapat negative ang sign. Tama, di ba? Ayan, no? Look at this. Negative of what? What's the minor? It's negative 1, right? So as I said earlier, for the determinant by expansion of column 1, you have to encircle muna and then check the array of signs for the numbers beside. So let's try determinant of B by expanding row 2. So where's row number 2? Ito, row 2 daw. So row 2, you'll notice that the elements are 0, 4, and negative 1. Yung 0, wala tayong problema. Pero, look at the second row. What are the signs? The signs are minus plus minus. So, this is minus plus minus. Now, what are the minors? The minor of 0 here is 2, 3, negative 3, 2. Of 4, that's 1, 3, 0, 2. For negative 1, it's 1, 2, 0, negative 3. So here, the first one, we don't have a problem. That becomes 0 immediately. So this is 4 times 2 minus 0 plus 1 times 3 negative minus 0. So you have 8 minus 3 is 5. So what do you notice, guys, in here? What you'll notice in here is that no matter where you expand it from, the determinant of B will always be the same, no matter what the technique or no matter what the method is, even if it's expansion or it is diagonal multiplication. Why? Because again, sige nga, Nina, what is the definition of determinant again? So no matter what technique or method you have applied, that number will always represent the matrix. So, eto, nag-diagonal multiplication tayo. The determinant of B is 5. Here, we expanded column 1. We got 5. He expanded row 2. We still got 5 because 5 is equal to your matrix. No matter what you do, matrix B is equal to 5. The 5 is the determinant or a representative number that is equivalent to your matrix.